Yeah, happy new month to all my subscribers and every other person watching this video. Yeah, now last month we talked about the number based system. We are done with the numbers based system, and in my last video I solved a particular kind of question and the number based system, and I said we'll be going into the next topic, which is what the modular arithmetic. And here it says modular arithmetic is a system of arithmetic that wraps around after reaching a certain value called the modulus. Now, what does it mean by that? It means that whenever we are trying to deal with a modular arithmetic, there are two things we should take in place. Number one, the remainder, which is also called the residue. Do we get that? So that is where we must note about what the remainder. We must know what the integer entails. So in terms of this, what does this matter? That is, the modular arithmetic is just trying to let us know that is whenever an integer is divided by a fixed non-zero integer, are we good to go? Then, and it gives a remainder, then it's said to have undergone a modulus. Are we good to go? And this modulus is, you can either call it a moduli in terms of its plural form, or you call it modulus in its singular form. So the first thing here concerning modular arithmetic that we'll really talk about here, because we are just starting this particular kind of topic, is that I really want you to know that whenever you are dealing with modular arithmetic, it's just like number-based system. In terms of number-based system, I told you that it must not, whenever we are dealing with the addition of numbers in number-based system, once we had and we found out that it is up to the base, what do? We divide. Or if it is more than the base, what do? We divide. So that's the same thing here in this particular place. In terms of number-based system too, we deal with the remainder. So once we divide, we write out the remainder. So likewise, the modular arithmetic as well. So we must take note of the residue, which is the remainder. That is when an integer divides a fixed non-zero integer, and it gives a remainder. So that is called modular arithmetic. So the first thing here we just really have to talk about is the integer. That is, modulo can be in any form. It can be in modulo 1, it can be in modulo 3, modulo 4, modulo 5, modulo 6, modulo 7. So if I are to tell you that, write out the integers of modulo 5. That is, let's start with this. Write out the integer of modulo 5. So what does it entail by that? That if we are told to write out the integers of modulo 5, what does it mean? It means that you should write out the numbers from 0, but must not be up to the mode. Do we get what I'm trying to say? Just like the number-based system, in the process whereby we had and we found out that it must not be up to the base, and if it's up to the base, we divide. So the integers in modulo 5, they are what? 0, 1, 2, 3, and what? And 4. These are the integers in what? Modulo 5. Do we get that? So that's that concerning this. So if we are told to write the integers in modulo 4, so what are that? That's 0, 1, 2, and 3. Do we get that? So if we are told to write integers of modulo 9, that is 0, 1, 2, 3, 4, 5, 6, 7, and 8. So that's that concerning this. Now, then after understanding everything concerning this, don't forget we must deal with the remainder in terms of mode. So that is, let's start solving questions, because we have a lot of things concerning this modular arithmetic. We'll talk about the clock, we talk about the tables in addition and subtraction of modulo, and we also solve some equations in modular arithmetic. Are we good to go? So firstly, we've talked about the integers. So now we'll be talking about the simplification of the following in mode. So in any mode that is being given to us. So now let's do with example 1. Okay, before example 1, let's just write simplify the following. So example 1. So if we're having 12 mode 5, if we're having 12 mode 5, So what do you think we are going to do? This 12 is more than the mode. So what are we going to say? So we'll say 12 divided by 5. So 12 divided by 5. So 12 divided by 5, what are we going to have? We'll be having what? 2 remainder 2. 2 remainder 2. Do we get that? So that is, we are dealing with the remainder. Yeah, so the answer will be what? 2 mod 5. Do we get that? So that's that concerning this. Or you can also try another particular kind of method, but that method is just very, very, very long. So how does it work? That is, you just have to be subtracting 5 from the number in front of the mode. So what does it mean by that? So you say 12 minus 5. That is, the question says 12 mod 5. So you can say 12 minus 5. What will you have? 7 mod 5. You get that? You can still see that this 7 is still greater than this. You can see from the beginning 12 is greater than 5. So I subtracted that. So 12 minus 5, that's 7. 7 mod 5. 7 is still greater than 5. So I'll still subtract 7 minus 5. What are we going to have here? That's what? 2 mod 5. Do we get that? You can see that it correlates with this. So we are just simplifying the following in this particular kind of mode. So if we are to solve another question, let's say we want to solve questions on example 2. This is our example 1. In our examples 2, example 2, so if we say we're having 31 mod 8. So in terms of 31 mod 8, what do you think we're going to do concerning this in 31 mod 8? So we say 31 divided by 8. So 31 divided by 8, what are we going to have? How many times will 8 go in 31? That's what? 3. Remainder. Because 8 times 3 is 24. So 31 minus 24, what are you going to have? You'll be having 7. So the answer is what? 7 mod 8. I will go to go. So we're having what? 7 mod 8. And if we also want to try the other method, which we all know that it is very, very, very long. So what are we going to say? We'll say 31 minus 8. 31 minus 8. Okay, let us try it right. 31 mod 8. So 31 minus 8, what are we going to have? We'll be having what? 23 mod 8. 23 minus 8. 23 minus 8. What are we going to be having? We're having 15 mod 8. And 15 minus 8. What are we going to have? 7 mod 8. You can see until I get to the smallest number that is not up to the mode. That's where I had to stop. So you can see that it correlates with this. So this is just the beginning of how it entails. That is, whenever we are dealing with modular arithmetic, you must take note of the remainder, just like the number-based system. So I will go to go. So that's that concerning this. So you can see that we are making use of the remainder in this aspect. So we've been able to do 2 questions concerning it. So yourself, you should be able to form any question yourself and solve based on simplifying any mode that's been given to you. So you can decide to use mode 8, mode 10, this and that, but just make sure that whenever you are solving any question related to this, you are dealing with your remainder. It is your remainder that you write as the answer, and you must ensure that your remainder must not be more than the mode. Do we get it? So if your remainder is more than the mode, what will you do? You still keep on dividing. You can see in the process of subtraction here, you can see that when I subtract here, I had 23. 23 is still more than this until I got to the smallest number that is not up to the mode. So the way get that. So in our next class, because I don't really want us to rush this topic, so I really want us to take it one after the other. So we get that. So in our next class, we'll be talking about the addition, we'll talk about the subtraction, and we'll also branch in drawing tables of solving integers in modulo 5. That is the addition of integers in modulo 5, and so on and so forth. Thank you.